Hello. In this video, we're going to go over a prisoner's dilemma involving two people, whether they're going to choose to advertise or not advertise within their industry. When we go over prisoner's dilemma, we need to understand what Nash equilibrium is. A Nash equilibrium is an equilibrium where we choose that isn't our optimal choice based on our strategy. So let's just go into it. Right away, the options for Kyle are to advertise or to not advertise. Rose's options are also advertise and not advertise. And this is how much profit will change based off of, right? Profit will increase by 10 for both if they both advertise, 40 for for Rose, 0 for Kyle if Kyle doesn't advertise and Rose advertises. If Rose doesn't advertise and Kyle advertises, Kyle gets the 40 increase, Rose gets none. And if they both don't advertise, they finish with a 30 each. So there is clearly an optimal choice here. The optimal choice is here. However, if our Nash equilibrium doesn't bring us to that option, we are at a prisoner's dilemma. That is how that works. So what we need to do is find our Nash equilibriums, which is based off of strategy. So first, I'm going to take don't advertise. If I say Kyle chooses not to advertise, what is Rose's best strategy? Well, if we see, and let's kind of write this down. So if Kyle chooses don't advertise, don't add, we have to decide what is Rose going to do? Well, Rose is going to choose to advertise. And why is that? That is because 40 is bigger than 30 outcome for profit. So Rose will choose to advertise since 40 is greater than 30. Her options are either if I don't advertise, I'm going to get a 30 increase in profit. And if I do advertise, I'll get 40, which is what we prefer. So Rose will choose 40 and advertise there. Next, we're going to decide, okay, well, if Kyle decides, hey, let's add, we're going to add. What would Rose's response be? Right? We have to find Rose's response. Rose's response would be, and if we look at the chart once again, we see, all right, Kyle is advertising. Rose's best response would be, again, to not advertise. To advertise. And why is that? 10 is greater than 0 here. So again, we want Rose to advertise because the outcome of 10 is greater than 0. And that is that is what her strategy should tell her to do. So we have both Rose's, no matter what, Rose's best strategy is to advertise, as we can see from both options. Next, let's find Kyle's best response to if Rose decides the strategy. So if Rose were to advertise, let's start with don't advertise. If Rose were to don't advertise, Kyle's best response is to, and if we look at the chart, so Rose does not advertise, Kyle's best response is to advertise. And that is because 40 is greater than 30. We see that here, 40 is greater than 30. And then again, if Rose were to advertise, Kyle's best response, again, surprisingly, is to advertise. And why is that? 10 is bigger than 0. So now we have found our Nash equilibrium. The equilibrium where we both decide that we are going to advertise, and thus we will end in this situation here. Where's the highlight? We will end in this, that's not the highlighter. We will end in this situation here, which is not our optimal. We are both better off if we do not advertise. However, our Nash equilibrium states that our best strategy to whatever the other person does is to advertise. Thus, we have a prisoner's dilemma, and we are stuck at an equilibrium that is not optimal, and that is based off of our best strategies. And that is it. That is how you solve a prisoner's dilemma. This happens all the time within the economy when it comes to advertising into two firms within competition. Other than that, if there are more economic things you would like me to cover, or a different example of this type of prisoner's dilemma, or a game theory with a first mover advantage, second mover advantage, or a no mover advantage, I will make videos for those. If you would like a specific one, please just send me an email. Other than that, hope everyone has a great day.